Hello everyone, and as he introduced, I'm V now. I started out as a software engineer and then moved on to the coolest and whatnot and the latest of the cloud and data and the ML engineering side of stuff. And then currently I work as a developer advocate at Snowflake. And interesting, I did not move the slides. But yeah, anyway, so today we're going to talk about how do we go from taking the raw data and building an interactive data application all within Snowflake powered by Python. And just by knowing only Python, how can you literally build an end-to-end data pipeline all the way up to a data application for your business users. But before we get into that, let's understand the motivation behind it. But why do we want to use only Python to build an end-to-end data engineering pipeline? Because today we do have different tools and technologies, and the data engineering stack is filled with myriad of tools that you can use for very point solutions, meaning for a specific use case you have a specific tool, and then for a whole different use case now you have to learn a whole new tool, talk about data quality and observability and monitoring, and it's just endless, right? With the limited number of resources and time and effort you've got in your data team, there is no way that we as data engineers can learn all these tools, or it's not even optimal for us to just go and learn every single tool that comes up in the market. And then there are some tools that are more like a platform that gives you that features and products that you need to accomplish these end-to-end goals. Even those tools, for example, are not very easy for folks to get started, right? Like if I am thinking about Spark as a data engineer, I cannot even go on the list of problems that I face on a day-to-day basis that I'm not particularly enjoying as a data engineer. Like, have you ever had to troubleshoot or debug a specific error, going through the pages and pages of stack traces and trying to find the needle in the haystack of, oh my god, what really went wrong? And do I even have to talk about the number of out-of-memory errors we've all faced and go and increase the driver memory, so let's just get this done with? And also, because of the features and the capabilities of these systems, they don't come easy. In the sense, you don't just go get started and be able to deliver data to your customers. You always have to go through this, managing this infrastructure and managing upgrades, upgrading from Spark 2 to 3, I'm sure must not have been fun for a lot of us. And again, not just about that, right? There is also capacity planning and the resource sizing, what's the right cluster to use and what's the right memory. And I have also a bunch of things like, we've talked about executor memory, driver memory, out of memory issues. There is one end of it, which is whole memory management problem. But then there are also tools and resources available as to how do we tackle these problems. And if you have ever prepared for interviews, you would be going around reading 100 blogs or probably even asking ChatGPT on how am I supposed to configure these variables, like what are the right values for these configs so you can run a fine-tuned Spark job, right? And I literally have tons of, it's just endless, like config after config after config of trying to tune your Spark job, and it's not easy. And once you do all of that, there is always that one catch in the end, which is even if you do find a resource or find a setting that works for a specific job or a use case, there is never a one-size-fits-all solution, So when you do have another pipeline that deals with a whole different data set and latency and use cases, now you will be doing everything all over again, trying to fine-tune that specific Spark job. So this one, trying to identify the right configs and settings and maintaining the infrastructure is an endless pain for data engineers, which should not even be our main focus. As data engineers, we should care about delivering the right data for our business stakeholders so they can go and do all these data-driven decisions, make all these data-driven decisions. Now, again, this is where Snowpark comes in. What is Snowpark? Snowpark is a set of libraries and runtimes offered by Snowflake, and it lets you, it supports different API clients. For example, you can use Python, Scala, Java, and whatnot. And the biggest differentiator with Snowpark is that you need to do zero configs. You don't have to worry about what's going on underneath and the storage, what's the driver memory, executor memory, what is the number of executors you need to set, and what is the parallelism and the number of executor nodes. Nothing. Zero configs at all. Like you said zero configs before you even get started with your data pipeline, so to speak. Now, just to give a quick overview of what it is, like it gives you those three client APIs, Python, Scala, and Java. And the best part, of course, we talked about all the complexities involved in today's systems. And also the best part about what's there today is this DataFrame APIs, because we are very familiar with dealing with data in a relational and a structured and a tabular format. DataFrame abstraction works very well for us, and then we are very familiar with how to use it. And the use of the data frame API and use of the data frame abstraction to using Python on Snowpark within the Snowflake environment is the best deal here. Zero configs, zero infrastructure management, only use Python, and you get to use data frame APIs, which you are very familiar with. Like the learning curve is not at all steep. You just get started and start using it. All you need to know is Python, which most of us here are very familiar with, especially for data engineers. Now, and on the client side, of course, we talked about having data frame APIs, and how do they actually run internally, if you can dive one step deeper. If you do write your data frame APIs, they get converted into SQL queries, and then it is run in the SQL engine that Snowflake already has, which is the super proprietary, a fast and cost-effective engine, and it works very well for your query side of things, right? But what happens when you have to use an external library, for example? You're using some external library and you're using the functions that come with it, and what if they cannot be converted into a SQL code directly? Because you can think of not every operation that you do within your data frames may not be able to be converted into SQL. For those use cases, you can wrap your external libraries or any other dependencies into a UDF, and then it would be run in the Python sandbox environment, again, all within Snowflake. But all of this happens internally, so all you are writing on the top level is just Python data frame APIs and nothing more. And now, taking this simplicity one level further, how does this apply for the streaming world? So what is Snowflake doing for the streaming world that makes your streaming pipelines even more simpler and easy to manage and less complex? Here's where comes in dynamic tables. And dynamic tables, as I talked about, one of the most important values at Snowflake is making things simpler, making tools simpler for folks to use. So dynamic tables kind of piggyback on that core value, so you don't have to manage your own dependencies and having to deal with 10 different tools again to do the orchestration of it or to do the data processing. Well, you don't need to learn Java for one, even when you're working with stream processing tools. And again, the biggest redundant operation that happens in the streaming world is that how inefficient it is to actually reprocess the entire data instead of incremental processing. And we all know the importance of incremental processing and why we really want to go for tools that do incremental processing for the incoming data. And to tackle all these challenges is where dynamic table comes in, where it natively supports both continuous and batch pipelines. You can look at it as a unified data pipeline for all-in-one solution. Again, no infrastructure management. And of course, it is cost-effective because you're doing incremental processing. You're not reprocessing all the data all over again as and when they come in. And it is native to the data cloud in the sense dynamic tables are within the Snowflake environment, so all the governance and the security boundaries are applicable to your dynamic tables as well. So you have the governance taken care of it just because it comes within Snowflake. And why dynamic tables? Why should you care, and what are the latencies looking like, and how does it compare with the existing streaming technologies that you already have? And today we are at Current, so there is Kafka and Flink and so many, there is Spark streaming and so many other, streaming technologies. And where does dynamic table fit in, or why do you even care? I guess one of the biggest, challenges when we think about streaming is all of us are thinking streaming means instantaneous, but it's not like that for the rest of us. There is this long tail of companies whose use cases are near real-time and not necessarily mission-critical real-time systems. So if you think about use cases such as just inventory updates from a retail setup, having the inventory updated, every 10 minutes or every 15 minutes is near real-time, but not exactly mission-critical. And you don't want to work with extremely complex systems to set up and manage and configure just to get to that near real-time systems. So dynamic tables and Snowpipe, like Snowflake, cater to this specific workload where your latencies are like sub few seconds and not in the millisecond latency rate. And again, of course, the cost, right? So even though if you do for, let's say, like every 10 minutes, if you want to keep your retail inventory updated, and if you want to go for one of these complex, heavy to manage, like difficult to manage solutions, it's not just about having those solutions for a smaller problem, but it's also how costly that is. It's just real time and near real time. They don't come easy. They don't come cheap. Like you have to pay the cost to get any returns out of it. But then is that even worth it for your use case, for your data, and for your industry, for example? So there is this long tail of companies for which it is an overkill, and that is where dynamic table fits in. And now, so how does a streaming setup with the dynamic tables and Snowflake, look like? Let's say if you, Okay, so let's say you have all the data sources coming in from different data applications or like transactional processing systems and whatnot. You can have one of these connectors, say Kafka connector, for example, ingest these data rows into one of the Snowflake tables, or you can also use Snowpipe ingest, and I will go over the different ingest solutions that are available in Snowflake a little later in the slide as well. And once you have these, let's say, for example, Kafka, once you have Kafka write these data points into your Snowflake tables, you can create dynamic tables off of those Snowflake tables by declaratively, mentioning what exact transformations do you want on those tables without having to do any other configuration at all. And I will go over how do you create a dynamic table and how simple it actually is. And yeah, so now the next step, of course, let's dive into what are the different solutions available for ingest. And as I mentioned before, real-time and streaming is a spectrum. And what real-time means for one company and one use case may not necessarily be the same for the other, right? So to cater to this spectrum of data ingestion options, so what does Snowflake have? It has a copy statement, which is purely batch processing and bulk load of files, and it is not for like truly real-time systems. But then if you move further along the spectrum to near real-time systems, we have Snowpipe, which would continuously ingest your files into your Snowflake tables with about a median latency of less than a minute. And then on the other end of it is where we have Snowpipe streaming, which is supported by dynamic tables here. And these Snowpipe streaming is catered towards the real-time ingestion with latencies less than a few seconds, for example. And yeah, so another quick overview of what it would look like with having everything within your Snowflake environment. You have data, apps, and services. For the batch processing, you have copy statement. You could just bulk upload. On the streaming side, you do have like row sets of incremental data coming in, and you can use Kafka topics as well to push those into your Snowflake tables. And on the Snowflake end, you can either use the Snowpipe or streaming just to cater to different use cases. And on the other end, of course, you have different use cases. It could be like, BI, ML, analytics, dashboards, and whatnot. And you could also be sharing your data with external or internal customers using the Snowflake data marketplace and all of that. Again, to, dissect the streaming use cases into 4 different sectors. Like one, you have these connectors that you connectors to load the data from your transactional processing or CDC stream systems. On the other, you have Kafka Kinesis sources or like, Firehose that ingest your data into your Snowflake for low cost and latency profiles. And on the other end, you do have like a bunch of security, and log analytics is another use case where you would want to think about using Snowpipe streaming again. And IoT, I guess, it depends on like how specific latency, like what specific latency you are looking for at your IoT use case, but something that has like low overhead where you don't really need a lot of configs, and if it's not a mission critical system and if it is low overhead, I mean, if your use case requires low overhead and less configs, of course, would be a good use case for the Snowpipe streaming as well. Okay, so here is where we talk about how exactly do you create a dynamic table, and I keep talking about how simple it is and you don't have to manage the infrastructure and easy to config and everything. As you can see, all you're doing is literally running a create table statement, and in the select star, you can define your transformations that you want from your streaming data, and then all you're doing is mention what specific lag that you want, which is the schedule at which you want these dynamic table to refresh the data or to rematerialize the data that's coming in. And that's all you're doing to create a dynamic table. And no other configs, you don't have to set up, like there are like no dependencies whatsoever. All it is a SQL DDL statement, and that is it. And can you even imagine running a stream processing pipeline with just that? It's super cool. And yeah, so I guess the highlight of why dynamic tables are important and easy to work with is, of course, because it's declarative. You don't have to worry about the infrastructure behind it. You just declare the transformation you want, and Snowflake makes sure that you get the whatever materialized data. Okay, I don't know what's going on, but then I am not working with the slides at all. It just keeps moving at its own pace. So let's just try to keep up with that and see where that goes. So again, having SQL support is, of course, a very important thing, because you have a lot of our engineers, like data engineers, working with Python and SQL skill sets. So having SQL support and creating a dynamic table in just a create DDL statement is like super cool, and also makes it easy for data folks to get started in streaming. So it's not always like resource intensive or like time consuming for folks to really get started on streaming side of things. And then you can define the freshness in the in the flag where you can set the target lag, and then it supports incremental refreshes automatically, and it has a snapshot isolation as well. Okay, so now kind of to sum up everything that we talked about so far. So I think, oh my God, is this voice controlled?
It's part of your presentation. I think it's just on the start.
Oh.
So if you pause it, it should do that.
Okay, that's okay.
We don't have anything back here.
No, I'm like, but no, I really thought it was voice controlled. I'm like, how is it supposed to know it's supposed to move to the next one? But anyway, so let's like quickly sum up what we have discussed so far. So the first one is Snowpark, and how Snowpark DataFrame APIs lets you write Python code and and all the familiar DataFrame APIs to just process your data. The core underlining statement that I want to focus here is that how you don't have to manage any infrastructure, zero configs, you don't have to worry about resource sizing, capacity planning, nothing whatsoever. And Snowpark is mostly on the data processing side of it, right? And on the data ingestion side, we have Snowpipe streaming and dynamic tables. Again, how with very minimal configs and infrastructure and setup, you can get started with streaming ingestion and then data processing, all within Snowflake, only using Python, nothing more at all. And so another thing why you need to really go full stack with Python for data engineers is, as data engineers, we work with our data science and ML teams and our business users back and forth. And if you have to use different tools, and then this whole passing the data product or the data pipeline over the fence, always has a lot of context that gets lost. Let's say if you're a data engineer building a data pipeline for your ML engineer, you have your data, and then you pass it along to your ML folks. Now they work with that specific data, and then they do their feature engineering, ML training, and whatnot. And once they have the model ready, and they want to, deploy that model in production, it comes back to data engineers to build the deployment pipeline, meaning you want to now automatically schedule how frequently the training needs to be run and everything. So the data gets passed back and forth between data engineers and ML engineers, and it's the same with your business users too. And when you do have this happening, you would, there are some companies where data engineers would do everything end to end, but then there are some companies where you would have different folks doing different things, and enabling Python across the entire data stack would make it easy for folks, and there is no context lost whenever there is this, back and forth communication that happens between your engineering team. As you can see here, it's like the communication or the flow is not very linear. There is a lot of back and forth involved between your development and ops and the business teams. All right, so now we're done with all the slide decks. So let's dive into the demo that I have put together. And it's a live demo, and I hope now I have control of what I'm showing on the screen and not at the mercy of the clicker. Okay. Okay, so first thing, I have my Snowflake environment. I just spun up a free trial. It's free for everyone to get started on. And I have put together a bunch of create statements. It's just I'm creating a warehouse, which is essentially a compute cluster, a database, a schema, and everything, just so I have some containers to later add the data into it. And I'm just working with a bunch of CSV files, nothing so fancy. So I'm just creating a file format and the stage for that as well. And I'm creating a campaign spend table. So in the demo, we're gonna see how a company, a fictitious company called a ski gear company, can go and optimize their ad spends. And let's look at the ad data, the spends and the revenues, and see how they can go and optimize it. So we're building an ML pipeline to optimize the ad spends for a fictitious company here. So let's create a table called campaign spend to capture all the spend related data, and then another table around the budget allocations and ROI. Let's just insert a bunch of example values so we have some data to work with here. And once I have all of this set up, I have this, as a data engineer and Python lover, of course, I had to put everything into a Jupyter notebook, because if not Jupyter notebook, then what else? And like I said before, Snowpark is a set of libraries and runtime. So all I need to do is pip install Snowpark and then import Snowpark into my notebook and then run with it. And as you can see in the config side of it, when I am creating a session, and if you are using Spark, for example, when you are creating a session, you would give in a list of all the configs and parameters and variables. And all I'm literally doing is the connection parameter, so I can connect my Jupyter notebook to actual Snowflake environment, which has this, the user and role and databases and schemas and nothing else. Zero infrastructure and configs whatsoever. And just like how you can run your pandas and PySpark DataFrame, transformations, you can just read the campaign spend table that we already have in our databases. Okay, so I have the campaign spend. It has just a few columns, which campaign and what channel, and the clicks and the costs and the ads served. And so that's all I have. So let's just read that, the campaign spend. Okay, so this is how it looks like, very similar to what we read in our table. And okay, so this is how our campaign spend looks like, and we have it per channel for every date. And let's go ahead and aggregate that for, I guess, monthly, what it looks per month. And if you can see here, so let's go ahead and group by date and the channel. So we will have the total cost per month. So for every month per channel, what is the total campaign spent? But again, if you look at the query that we're running here, the DataFrame APIs, they're super similar to if you have worked with PySpark or Pandas before. And again, there is zero heavy lifting involved. Even if your team is already trained on Spark, there's nothing new that you need to learn to really get started with Snowpark, for example. And okay, so we do have the aggregated data per month per channel, and now let's pivot it into columns. Like I'm pivoting based on my channels. So let's on search engine and social media and video and email, how do the spend look like? And once I have that, let's save this table, which this spend per month, into a Snowflake table and write it back. And again, if you look at the API, looks very familiar because we've all worked with Spark and Python before. So this is exactly very similar to what it looks like. And okay, so here I'm just doing ad hoc transformations, but let's say if you do want to schedule it, orchestrate it, which we all do, you can put the transformations into a UDF and then or a stored procedure, and then we can also one sec. Okay, so once you do have the stored procedure ready for your transformations, you could simply create a task to periodically run it. And again, so here I am creating a task and then altering the task to resume and suspend. But recently we also have tasks API, meaning you can run this also in Python instead of just SQL. But again, so if you do have your transformations in the form of a stored procedure, you could automate it with tasks. So your scheduling is also done within Snowflake's, like literally everything end to end in data engineering you should be able to accomplish within Snowflake. And okay, so the next, we did some data processing and aggregation on the campaign spend. So let's look at what the revenue looks like. This is how the revenue looks. Let's group it by, again, aggregate by the year and month, and we have the monthly revenue. So now let's join the monthly revenue and the campaign spend. Again, if you look at it, there is nothing about, there is no configs that you need to set about, do you want to enable broadcast joins, or there is nothing at all on the infrastructure, on the internals that you really need to define or need to worry about. And very similarly, you can also do an explain and look what the query looks like internally. So when you do run a specific data frame API transformation, I did mention that it gets converted into a SQL query internally, and then it is run by the Snowflake SQL engine. So what does the SQL query look like in the execution plan? You will be able to see by doing the explain. You can see internally what are the number of partitions and bytes and but again, as a data engineer, you are not worried about how many partitions should your data have, what are the optimal number of partitions, what is the partition size, no configs whatsoever, it's all taken care internally. And so once we do have, once we combine our revenue and spend together into a data frame, let's write that back to Snowflake as well as an intermediary table. And we will use this as a feature table for our ML workflow later. And again, like I mentioned before, for the automation side of it, you can create tasks and enable alerts and monitoring of every successful run of a task and whatnot and all of that. And you can see all the Snowflake objects associated with this specific table here as well. So you will be able to see the specific task and what is the frequencies, like for every task, what is the compute you're using, what is the warehouse, what is the schedule, and who's running it, and when is it run, and all of that details as well. So this is on the data engineering side. We read a couple of tables. We did some aggregation, grouping by, and pivoting, and then we joined a couple of tables, spend and the revenue, and then we wrote the data back. And now let's forget about the data engineering side and move on to the ML side of things. And what does our ML engineering, or ML training pipeline look like? Very similar. If you have worked with scikit-learn as a data science person, you would be familiar with all the tools and the functions that we have, like the transformers, features, scalars, and all sorts of pre-processing and training functions. And again, so if you have worked with Pandas API and scikit-learns and NumPy, it is super easy to get started. And even the each of these APIs are like, have one-on-one matching, so you don't even have to worry about learning a whole new set of APIs and tools for the same thing. And again, so we did have like revenue per month, and let's just, read the spend and revenue per month, and then let's go about creating our features. And I'm like, first step, I'm just gonna do a, I guess, column transformation where I would define the steps as, just do a standard scaling of your features before you use it for your actual training. And you want to do this standard scaling only for the numerical features. And once that is done, let us go ahead and run a simple like model fit and train. And once that is there, once you have the model, which is a simple logistic regression model, you could just, save the model back as well into your Snowflake environment. And you would be able to see the functions here as well. So once you do have the predict function, you will have all of that together within, all the Snowflake objects together related to your database. And very similarly, you can create UDFs here again. If you want to automate it, the best way is always to create a UDF and then put it on tasks. So the specific UDF will, keep running on a set schedule. And so I'm just, redoing the same transformations just in a UDF format, so it is reproducible. And so once you do have the UDFs, you could, define what are the parameters that you want them, in terms of the sessions, and then where do you want to store the UDF, and a few other, where does the UDF load the model from for the predictions and whatnot. And so that's pretty much it. And once you do have all of that, again, in the end, if you think about it, so we have a data engineering pipeline, we have an ML training that's running on, and on the other end, to build a data application, for example, we have Streamlit. So Streamlit is an open source library for building creative UI for any application, really. So if you have worked with Flask or Fast API in the past, it is, I would say, Flask on steroids. Again, very minimal configs, super easy to get started. So even as a data engineer who has no experience building anything on the front end, you would be able to, build beautiful dashboards and applications that are interactive with Streamlit. But interestingly, only I guess a couple of weeks ago, Streamlit is now available within Snowflake as well. And what it means is that, so you can now go ahead and create Streamlit applications for any data that's already available within your Snowflake environment. So all you need to do is just create a Streamlit app, and I would just call it just a demo app. And I'm happy with the warehouse and okay, so it is the database that we're working with. And literally, if you look at it, this is just a sample code it gives me, but then if you want to go over the code, it is using one of the data frames that we have, and then it's just plotting the data frames. And if you look at it's even the number of lines of code it takes to actually, put a UI app on top of your data is very few. It's 15, 20 lines of code to actually create a data application. And the interesting part is this would get updated as your data gets updated, right? So you don't have to imagine real-time dashboards getting into your Snowflake environment. So you truly have our backend governance and access controls, everything within Snowflake, all the way till dashboards or the data applications. And that's pretty much all I had for the demo today. And if you do want to get started or give it a try, if you want to start with the raw data and go all the way into building a data app within Streamlit, or get started with Snowpark and dynamic tables and whatnot, you can go over this quick start, and it should guide you step by step on what to run to get there. And that's about it. Thank you so much.